So I'm Jeroen Donkers, one of the researchers in the project, and have the task to explain how we implemented learning analytics in this project. Just a summary, learning analytics is a way of using data that students produce to improve learning by analyzing the data, transforming the data, and translating the data into interventions. And in this project we understood it like this. The data we have is the data collected in the e-portfolio, as Jeroen produced. Is we want them to have just-in-time messages about developing on the moment that they need those messages. That was our goal. And the way between data and the messages is our student model. So what is a student model? A model has many different meanings, but here we mean by student model a representation of relations that play a role in, well, in workplace-based learning. For instance, the performance, the motivation, or the consistency. Okay, we use a special type of student model, a student model that is based on a Bayesian network. A Bayesian network is a statistical that is grounded in classical probability theory, so it functions very nicely, and it allows the prediction of the inner state of a student on the basis of observations that you make in the portfolio. Well, we use a special type of Bayesian network. We have to be cutting edge research. So a very new, a very exciting version of Bayesian network is the multi-entity Bayesian network. And that makes it possible to take the context of a particular student into account. Normally all students would be equal. In this case you can make changes between or differences between students. And it also allows a more clear way of defining the student. Okay, so what do we put into the student model? Well, the content of our portfolios. Well, not the pure content. We try to generate findings from the portfolios. So, for instance, we look at the score development in a portfolio for a certain EPA, and we see a sudden drop in score at a certain point of time. That would be a finding. Just like we have findings on patients. You measure temperature, oh, we have a rise in temperature, okay, that's a finding. Okay, these things have to be generated from the data and are input into the student model. Then the output of the student model is a posterior probability. That means that we have a set of variables that represent the student, and for each of the variables we have the posterior findings that we have for the student on the state of the student. For instance, we can have a probability of 0.7 that the motivation of a student is high, or 0.3 that it is low, because there are only two states there. Okay, and this output of the student model is then used to generate messages by the system. So you can decide probability on motivation is higher than 0.5 on a low motivation. Then you would send a message, well, please go talk to your supervisor, because we have a suspicion that there might be something wrong with your motivation level. Or maybe a better way of phrasing that. So it's very careful, you have to be very careful on how to phrase these messages. Okay. Now, as Jeroen already told, we developed two different student partners in the project. University of Reading and Maastricht University were involved in the student modeling, called the performance model, and we have developed the pedagogical student model. And naturally I will tell a little bit more about the pedagogical than about the performance model. Well, the performance model tries to estimate the true present level of performance. And it does that per EPA, per enhanced and trustable professional activity, and per performance indicator for each EPA. And the pedagogical model deals with behavioral and metacognitive aspects of learning. Well, I'm not going to all these notes and arrows really mean, because that would take an hour, but what it does, it takes the performance or the scores for each EPA and then compares the score between time steps, performance, some type of smoothing using probabilistic table, and then says, okay, given your previous score and your current score, we think that there is a probability of 0.4 that you have a level of 4 at this moment. Okay, little bit insight. What's happening? Information comes into OneNote, is translated in a table. This blue table says, okay, we see that you have a positive supervisor feedback at this moment. Well, we also see that your current score is at level 1. Okay, those with a lot of fuzzing around gives, okay, we say this combination means that your true level 84% at level 1 and 52% at level 2. So combination of this and the combination of what we already knew from your score is now 1, but it might be that you're, well, half-half, that you might also be at level 2 at the moment. Okay, and this is what the performance model in fact does. So it takes things, it smooths, combines information and says, okay, it spits out the probability on each of the levels that you can be. And the output of this model then is translated in the most probable state, and this will be graphically presented to the students and later on in the model. The pedagogical student model was a different story, because what you here want to do is to reason about well, what's happening inside the student, what is learning process. Not his performance, it's okay that we know that with scores, but what's happening with the student. Well, there are many aspects that are relevant for workplace-based learning. So we did a round of interviews with experts on the area, 10 of this department and people from outside the department, and we made a mind map of all the things they mentioned and all the aspects, competencies like performance, like motivation, like role modeling, etc. And we took out some of the aspects. Okay, we have only 3 years of project. What could we do inside this project? And we were already halfway. So what can we do in the last year in the project to really build this model? And we took 4 teams that think, okay, maybe we can do something with that. Fragments, so pieces of knowledge that make together the student model. And the first one is, okay, it's called feedback seeking behavior. So we know that in many situations in workplace-based learning, the students themselves ask for feedback and seek for feedback. They have to ask somebody to give an assessment or to look at what they do and then give an assessment. And they have to select the people themselves. And in the way they select, you can learn something about the student. So if they only select peer students that will give them very high scores, friendly guy that always gives very nice scores, you know there's something wrong. They should spread their feedback around different people, and then you get a more objective feedback on your behavior. So we can check that very easily. So, okay, if you're only selecting one role in a time point, it's not good. Or when you select too little feedback, it's also not good. So that's about feedback seeking behavior. Frustration alert, it was a very sexy term. What you think there, well, we know from literature that there's a lot of problems with burnout levels especially in medicine. So the idea was, can we not find signals in a portfolio that might hint to a possible high level of frustration or low level of engagement, which might be counterpart of that. So we looked at some signals, and we explain in the next slide a little bit more with signals with. And then the model will output, well, there's a high probability that this student might be frustrated, or low probability. And if it is a high probability, you might want to send a message, maybe not to the student, maybe to the supervisor about this finding. The third one is completeness of information. Well, if you look at the variation of scores in a period of time, and not the growth, but the variation at a certain point in time, it might be that in one of the areas you have much more variation than the scores. And that area of high variation might mean that you might need more information in that area. So the reliability for that area might be lower. So we check in which areas at a certain point in time you have more variance, and then we will send a message out from please collect more information on that area. That's what we mean with completeness of information. And the last one is portfolio consistency. Very difficult terminology. Some people in interviews said to me, well, that's very important, portfolio consistency, but we don't know what it means. So that we have to put it in the... So we interpreted like, how is, again, in terms of variation? Is there a big difference in variation between the areas, or is there a big variation in the portfolio in time development? So, and if that is the case, if it's not, the variation is not spread evenly over the portfolio, we say it's not consistent. And that's one interpretation, and we could have a lot of discussion and better interpretations, and we love that because we want to improve our models. But for now, we tried, okay, this is our definition, we tried to start with this. Okay, what we did is, well, all these elements I mentioned, they need some signals from the portfolio. They need to know whether it's a score drop or whether there is variation in the scores, etc. So we developed a number of procedures to extract that from the picture. You see for one student, the whole life of the portfolio. So we have 140 weeks. So this is complete time span of portfolio. And for every line, one type of signal presented. And for instance, well, on the top line, we check whether there's feedback from a peer student. And when, for instance, the purple line is high, you have feedback. If it is low, you don't have feedback. So this is a very simple signal that says, okay, when do you receive feedback? We also have things like, hotspot. That means it's one of the EPAs, one of the areas of interest. Does that EPA have much more variation in score than the others? Well, and we see that each one pops up now and then. And so each line is one signal that is extracted from the portfolio. So this is the input for a student model. All the signals are given into the student model. And then the student model, well, I only give a picture. Each node is like a variable in a structured equation model. You can really compare it to that. And we have inputs like, well, has the score dropped? Is there change in number of assessments? Did the mood of the supervisor changed? And we try to check that from the feedback text. And that together with, well, is the consistency and was the student frustrated at the previous time step? We combine this information in the output node that says whether the student, well, and each of the nodes, there's a table, a probabilistic table, that says, oh yeah, given that we have a high inconsistency and a significant change, what is the probability of being frustrated? Well, if you were already frustrated previous time, well, you have a percentage of 80 to be frustrated. Now, if you were not, it was 80. If you were, it was 95. Well, these numbers are estimations, and they are used to reason with the input. Okay. And what comes out of the student model? Well, knowledge into a big network in which all variables for all time steps are combined. And then we see that at time step 1, the student frustration, in this case, for this example student, was 78%. At time step 2, 21%, and time step 2, it raised to 77%. Okay, there's something wrong. This is not shown to the student, by the way. This is all internal in the system. Yeah, this communication is very important in this. So, but first you want to know, and then you want to show. Okay, this is what comes out of the student model, not to the student, but again, it looks like a picture you get from in the hospital when you're on ECG or something like that. I think you see for each of the knowledge factors, for each of the factors, you see a line, and higher the line, the higher the probability of that state. And for instance, we have this greenish line, and for this student we see, well, here's something happening, but here we have a sharp peak. Something must be wrong at this moment. So here you typically would send a message not to the student but to the supervisor in this case. Okay, and all variables are printed for a whole career of a student, so you really have a picture of the student in one page. You can really see, okay, what's happening with this. And this, to use at the moment, but in future this might be very useful for supervisors to have this whole picture and see, okay, oh, this is very typical for this student, and okay, you really see patterns occurring here. Okay, yeah, okay. For people that are going to join the technical workshop, I will go into detail in how to build the student model, these really work, and how you get those probabilities. Would love to explain that here, but then we need 1 hour. I give the floor to